Welcome to Curious Campus, where we talk to professors from various departments at the University of Toronto about a recent research topic they've dived into, breaking down these new developments for everyone to understand. Stay tuned, you'll definitely learn something new. I'm Chavi, and today I'm here with Professor Steve, and we're going to talk about his research in generative AI and music, and his new research about making games for forensic science education.
Hi, Chavi.
Hello. So, a bit of introduction about Steve. Steve Engels is a teaching stream professor at the Department of Computer Science here at the University of Toronto. While many students may know him best for his teaching computer hardware, artificial intelligence, and game design courses, Steve also spends a great deal of time researching artificial creativity, educational video game design, open data, and much more. Today, we're here to discuss some of his work, both old and new. First, we're planning on delving into something that's been 13 years in the making thus far: artificial creativity and automated music generation. Then we'll touch upon some research that Steve has more recently taken up, designing video games for forensic science education. And without further ado, hello again, Steve. How are you?
Hello, Chavi. I'm doing well. Thank you for having me.
So we're first going to talk about the work done in automatic music generation. And to bring us to this topic, I want to ask, now with what's going on in the world and like the public use of artificial intelligence, how is creating music using artificial intelligence different from, for example, the use that's being done with text and writing?
Well, for me, it's interesting because we were working on this before the term generative AI became so prevalent. We were just people who were working on using AI and natural language algorithms and just wanted to see if we could apply it to music. My research area before I came to U of T was actually in machine learning and natural language. So I was using learning algorithms in order to try to process text. And we were doing things like trying to look at text and identify, key parts of speech. But then there was a student who wanted to see if this could be applied to music because he had a deep music background and an interest. And so we were thinking, okay, well, we can use this in order to process music. But what would we do once we process it? And then the thought came, well, why don't we actually see if we can use this model that learns the patterns of music in order to generate original music that was in that style? So that's what we did. This was back in 2011. And at the time we were using, probably the most modern technology that was available at the moment. And yeah, it actually worked. We managed to generate music that was at least somewhat coherent. And we presented it to the larger research community. We took it to video game conferences where the main idea behind it was that we were going to use this in order to produce, background music for games for studios that couldn't afford a composer.
Yeah, and well, the main thing is like, how do you see that that's changed with people now using generative AI music, especially when considering like streamers on Twitch when they need to use that so they can bypass the copyright laws that would prevent them from using other music?
Yeah, that was one of the questions we got early on when we started presenting this at conferences. We got two main questions. One was, are you trying to replace us composers? And the second one was, how is this going to be affected by copyright law? And the answer we had to the first one was, no, we're not trying to replace composers. Like, we were trying to make something that was kind of in the style of, certain music, but it was never going to be as good because it was imitative, right? It could only produce music that was sort of imitating the original style of some other piece. And, something that was truly original was still only within the domain of the human composers. But then when it came to the copyright, that's really hard because there is we found, no truly original compositions, both music or text, everything produces, or everything draws from other sources in some way, like certain phrases or, certain ways of organizing one's thoughts. And music, it's often been an area where you can find samples of previous works or previous styles in current composers. And composers now will even say, oh yeah, I drew from like a little bit of Mary J. Blige and a little bit of Beyonce and a tiny bit of Taylor Swift in order to make my composition, right? So the idea of attributing some of where your piece comes from is nothing new.
Yes, of course. And that is like a main point with such a thing as music and other forms of art, where it's like, how do you define something to be original and not completely based on the works of others?
Well, before I came to U of T, I had actually been doing a lot of studies on invention and innovation. And what they found was that a lot of inventions tend to draw from previous sources, or try to take a solution in one domain and then map it over to another one. So yeah, we weren't really, I guess we didn't think too hard about how original the things we were making were, because I guess our understanding of human originality is that it's very difficult to be truly original, that, a lot of inventions or innovations are really just ideas that you've transferred from one domain to another, or, combinations of things you've found in multiple sources. So yeah, so our music does the same thing, right? It's not completely original, but it's not a complete transcription of previous work either.
Of course. And then with that notion in mind, then talking about creativity in the music that it produces, do you think that there are like elements of creativity, quote unquote, that musicians would appreciate, such as like comparing with deep minds like AlphaGo, where when it was playing against professional Go players, that they were considering their AlphaGo's moves to be creative?
Yeah, well, okay, so AlphaGo, in terms of the creativity, it was doing a lot of exploration, and just looking down different paths that, well, not that humans wouldn't consider, but just that the volume of different paths that you would have to consider in a game of Go is so large that humans couldn't possibly consider every single path. And so it would look down paths that others might not consider, and then look and find things that humans might not have known to look for. Was it creative? I mean, it was definitely able to explore new things, and by that definition, it was creative. But when it comes to music, the idea of creating something that is so, I guess there's the idea of being able to create something and being original. Making something original isn't necessarily good. And what we were trying to do is trying to make music that other creators would consider to be good, even if it wasn't something completely novel, right? Completely novel could be like absolute garbage, right? And people think that it's like, okay, well, you've never heard this before, so in that way, it's completely original. But I think we were aiming for good as opposed to new.
Okay. And with that in mind, then, do you think just aiming for good instead of new, that would mean that whatever was produced would have a lot of influences? So then would the new creation be credited to computer science who's developed the algorithm, or like the musicians?
I mean, I can't speak for all the people who use generative AI to make music. I know for us, we were intending it to actually be derivative. We wanted people to be able to identify the source pieces that it trained off of. Because what we were doing was we're trying to create something that could create like some novel piece in a particular style, so that you could feed it a piece like Bach and it would produce a new piece that was in Bach style. Right. And it was definitely recognizable in that way. Like, you'd be able to actually almost attribute some of the runs in the music to some of the portions of original pieces. But that was kind of the idea. I guess we try to compare it to, somebody who's almost like a parody artist, who actually takes some original songs and creates their own satire version of them, right? Like, you still want to be able to know, like, oh, I recognize this. This song was done by this song was done by Britney Spears, right? And I recognize her tone and I recognize some of her style. That was kind of what we were trying to make. And that was partly because in order to be able to know whether this thing was succeeding or not, we had to be able to hear it and hear Britney Spears come out of the song. Otherwise, we don't know if we were doing it right or not.
Yeah, of course. And that's fair with ensuring that tool for music. It's just, again, a tool and not supposed to replace any of the composers that are there producing the music.
Mm-hmm. I mean, really, we did want this to be for background music in games, so that a small, like an indie game studio in Toronto, and Toronto was filled with mostly indie studios at the time. They couldn't afford their own composers, but they knew what kind of style of music they wanted. So all they had to do was put in the style of music into the software, and then it would generate original music in that style in real time forever, right? And so that was supposed to be satisfying the need of these small studios that couldn't afford to hire a composer of their own.
Mm-hmm. And so based on that, there was that article published in the U of T magazine about this work in 2018. And there was discussion about like the music not being able to portray emotion because it wasn't coming from a human source. Mm-hmm. And so does that change how it's being used in, say, per games with like not portraying the emotions that it's supposed to at that time?
So it was fine because the original models that we were using, they were making things that were musical, but didn't have some overall progression to them, right? No overall start and overall end, right? And most pieces tell a story in that way. But what we were doing was we were creating background music, right? And it was fine because the background music would be something where if you're in a particular scene, then you'd have this kind of music going, and you didn't notice the fact that it had no end or no beginning because it was basically just there. And then what would happen was as you go from one section of the level to the next, it would then switch the models out, almost like putting in a new record. And then it would start playing music out another style that matched that scene. So for the target audience that we had, it wasn't a problem. But we did recognize that as this started to take on a life of its own and people started to hear about it, people wanted to hear an actual piece with a beginning and an end. So we expanded the model to try to create these hidden states that would actually show kind of the change in tone from beginning to end. What kind of notes would you generate at the beginning? What would you generate in the middle? What would you generate at the denouement? What would you generate at the conclusion? And so then we created a model that was able to do that. But the idea of emotion, that was mostly built into the piece that we trained off of. So if we trained off of a happy piece, we generate happy music. If we trained off of a sad piece, we generate sad music. And so the idea of being able to put emotion in would be up to the people using the software to, I guess, to train it off of a piece that had the style or the emotion.
Okay. Yeah, that is like really cool to just think of whatever you want, just make sure that your training data is good enough for it.
Yep, it's all about the data in the end.
Yeah. And also just taking things off that article that was published. It started off by mentioning your own musical background with all of the instruments that you had learned early on in life. And how do you think that your own history with music has shaped your perspective on the development of this technology?
Well, it's interesting because I grew up in a half Asian family, and like a good Asian family, I was taught I needed to learn piano from an early age and for a long time. And so I learned all about, the just different pieces and the different kinds of music and what was musical. But when we were actually doing this, we were trying to distance ourselves from our music background and look at this as data scientists, right? That a lot of the musical generation that had been done previous to that was trying to almost hard code musical rules and then try to generate something that satisfied those rules. And that had also been kind of the approach to text up to that point. People had created things like parsers and grammars that would take a sentence and break it down into like noun phrases and verb phrases and do that sort of decomposition until you got down to the words. And that was kind of how natural language processing had been done for a while. But then as we started getting into more statistical models, things that looked at the data and just looked at it as a data problem, then we started to get stronger algorithms and stronger results. So we actually had the musical background. We knew what we wanted we knew when it sounded right and we knew when it sounded wrong, but we also tried to make it all about the data as opposed to trying to let our musical background influence what we created too much. The only thing where the musical background actually like stepped in order to help make our data better was we realized that bars were actually important. Like we thought when I was growing up, reading music, I thought bars were just a notation, right? That you just put them in after every like 4 quarter notes. But as it turns out, bars actually do have some sort of structural influence that, the notes that you have in a bar are kind of like portioned, and that the bars, if you have 4/4 time, then those bars indicate where those 4 end. And once we actually realized that that was as important as any of the notes, then everything we generated sounded better. Like we realized the notes had to not only include what the pitch was and what the duration was, but also where it was in the bar. So yes, so that's one of the only times when our musical background actually stepped in and helped guide us towards a better result.
Okay. And then with that, how do you think, say, if this technology was there when you were learning, how would that have maybe changed your experience with learning or trying to compose new music?
Oh, I don't know. I felt like it was more of an exercise in discipline at the time that I was learning it, as opposed to like, expanding my musical horizons. I think that my parents would be pleased to know that all those years of paying for piano lessons led to something later in life. that I didn't lose it completely, although I have lost it completely. But that it actually kind of had some benefit to my overall career and research.
Yeah, that is fair. And then with that, to wrap up this topic on generative AI music, where do you imagine this technology being best applied?
Well, we've always wanted it to be something that, could help stimulate people's imaginations, right? It's like we were saying with things like Go, is when you're trying to explore a space of potential like game positions, you know, computers can explore a bunch of different areas that humans can't. And and so what we wanted to do was not to replace composers or even to make music that people are going to end up using, but we were thinking of it as like somebody who is composing and trying to figure out what to do. They would be able to use this tool to help spark their imagination the same way a writer would look up words in a thesaurus, right? Like you're still trying to come up with your own voice, but sometimes you just need like a little spark to light the flame. And, hearing a couple of things, he would be like, okay, well, that's interesting. And actually, it makes me think I would want to actually make something that's like this. Or still, background music for video games. I still hold out hope for that one. Yeah.
Now we'll move on to your newer research about making games for forensic science education. Sure. And well, there isn't much about this, especially since you had started on this last summer, right? So can you just tell us more about it and like why forensics and what progress has been made on the project, if any?
Well, I've been working on like video games for X for a long time. Because I'm the one who teaches the video game design program in our department, when it comes to making games for something, a lot of people have interesting ideas. Like I want to make a game for testing video game violence, right? So I worked with someone from psychology for that. I want to make a game that helps with the cognitive development of seniors. So I worked with someone else on that one. I want to make a game that helps visualize the molecular structure of minerals. Okay, so we worked on that one. People at Toronto Rehab wanted to work on a game that would help with stroke rehabilitation therapies. So we worked on the game for that. And so a lot of these end up overlapping with things like video games for education, right? Making games that can actually help teach people things while they're enjoying the activity, right? Because all games help you learn. When you're playing a game, you learn about the controls that you need in order to be able to play it. You learn about the strategies, the goals, there's always learning involved so that you can understand the game better and then become better at it. And so, so basically a lot of games end up just becoming like games for education, using that idea that you have to learn to play a game anyway in order to maybe learn something useful. So worked on a bunch of games for education. And then the forensics thing came up because at U of T, there are experts and, professors in every field, right? Yeah. It is, it has basically every subject area you might want to consider. And so sometimes when you meet other people outside of your department, then there's always these interesting collaboration opportunities. So getting back to your original question, why forensics? Only because I ran into at one of these little gatherings, one of the teaching faculty at UTM, so the U of T's Mississauga campus, in the forensic science department. And we just got to talking and saying, what would we do if we could combine forensic science and video games? Like what could happen? And then like we came upon this idea that in forensic science, like in our programs, they actually train them on doing like evidence collection and analysis. But in order to do that, they actually have to take, this mock scene and they have to stage it with fingerprints and other kinds of evidence in order for a single student to go in and like identify it and collect it. But then if they have a class of like 20 people, they have to do this 20 times. They have to clean up the room, stage it with more evidence, and then do this again. And that is incredibly time consuming and resource intensive. But if we make a video game out of it, something that kind of simulates what they would do in real life, then they can go through the process of learning the techniques for identifying and collecting evidence and then analyzing it without like some TA having to set this up every 20 minutes for an entire day just for a single class. Yeah. And the way they have it set up right now, I mean, it's great, but because they are limited on how often they can do this. It's mostly limited to assessment, like testing them. So there's no place for them to practice. So create the video game, allows them to practice the techniques and figure out what the steps are. So when they actually go in for their actual test, then they actually know what they're doing and they can get it right.
Yeah, for sure. And how would you say the experience would be different to people, to the students who may not be avid video game players to begin with?
Well, when we talk about these things being like games, they're only games kind of in a loose sense, in that we're using the game design tools. We're using some of the psychological techniques for kind of helping ease people along and rewarding them for getting things right and giving them formative feedback, but that's not too different from teaching. And so it's just the medium. I mean, they could learn from a person who's giving them the same advice, or they can learn through this virtual environment, but we see it as more of a simulation rather than a game. It's just a simulation is some more syllables, so it's a lot easier to say the forensic game as opposed to the forensic science evidence collection simulation.
And now for moving from physical learning spaces to virtual learning spaces, what do you imagine are the challenges that come with it?
Well, this is definitely just an approximation, right? There's a lot of things that they can't do in a virtual scene, like get a sense for how lightly to dust something in order to get the fingerprints to emerge, figuring out how to anchor the tape on one end and then smooth it with your thumb on the other. I mean, most of what we're doing is just helping them practice the sequence of steps that needs to be done, and making sure to, I guess, be thorough, and to remember what things you need to do so that when they actually get into the physical environment, then they can focus on the physical techniques as opposed to the mental techniques, like the mental checklist of what they need to do. Yep. So it's not meant to replace it. It is meant to just give them a little bit more preparation so that the in-person experience can be more meaningful.
And then what do you think it is about educational video games that makes users more comfortable to make and learn from their mistakes?
Well, that's actually it, right? Is that in person, there's this pressure to not make any mistakes, especially when it comes to things like forensics and, evidence collection, where the consequences can be so severe, right? If you miss a piece of evidence or if you process it incorrectly, then you could send the wrong person to jail, right? Or the wrong person could go free. And so there is a lot of pressure, especially on forensic science students, to not make any mistakes, which is a shame because mistakes are one of the best ways you learn from things, right? Like in computer science, we learn. You make a mistake, you see the error, you learn from it, and then you can go on, right? The person who gets it right the first time learns the least. So what we're trying to do is just create an arena where students can feel free to make mistakes, and enjoy all the benefits that come from learning from your mistakes. Right?
Yeah, that's fair. And then do you think that everything that's being done in the virtual and digital innovations then is it just supposed to complement what's already being done physically, or is anything going to take over what is being done?
Well, with any kind of technological innovation, our hope is that if it replaces anything, it's going to replace something that needs to be replaced. That we're not trying to get rid of the good things, right, along with the bad. So when it comes to the forensic science education games, it's supposed to give people an opportunity to practice where they didn't have the ability to practice before, and get rid of some of that pressure, some of the fear of making mistakes, and just give people that opportunity. When it comes to the music generation, we're not trying to replace composers, but we're trying to create a tool for those kinds of musical compositions that aren't the best use of a composer's time, right? Where things that are going to be truly original can actually be created by humans because that's what they have the capacity to do. But things that are like elevator music, you can relegate to tools that can help make that for you. I mean, it's like everything that we do, right? Like we create technology that allows us to print documents instead of having to handwrite them. We create technology that allows us to harvest more crops from a large area in, a fraction of the time that it used to take, right? Mostly just to try to ease some of those tasks that take a long time where like human cognitive abilities aren't crucial to make those things happen, right? So all the technology that we work on, it's all meant to just supplement the things that we already do, replace the stuff that needs replacing, but not meant to be like, oh, we're going to replace all of humanity with robots.
Yeah, definitely fair. And it's just a new creation of new tools, which has always been done. And with that, to wrap everything up, do you think there's any intersection between these two research topics?
Well, I mean, I guess there's me. What I tell my students is that all the research that we do tends to be like a culmination of the experiences that we've had, right? And my experiences have intersected with AI and music and just finding like things that I find really interesting, right? Forensic science is really fascinating. I've been learning about how to collect fingerprints and it's cool, right? Um, I feel like computer science allows us to, as researchers, get involved with all of these cool things, things that fascinate us in terms of what technology is able to do. So if I had to say where there's an intersection, I would say the intersection is in like all of the people who work in computer science and the kind of cool experiences they can bring and, find ways of applying technology to new areas that hadn't been explored before.
Yeah, it's always cool to see the overlap between different fields. So thank you so much, Steve, for all of your time. And that concludes our episode of Curious Campus. If anything you heard today interests you, stay tuned to this new research coming out and check out Steve's article in the U of T magazine. Stay tuned to Curious Campus.